talk.
Thank you. Great to be here.
Thank you very much for being here. Let's start at the start. What is geoengineering?
It's really two very different things, which have come under the same name, but have very little relationship to each other. One is ways that we would alter the amount of sunlight the Earth absorbs, and so cool the planet, partly offsetting the effects of carbon in the atmosphere, and that's called solar radiation management, or in some technocratic way, SRM. And the other one is to take carbon out of the atmosphere, so-called carbon dioxide removal.
So it's both reducing emissions, or dealing with the growth in emissions by taking the carbon dioxide out of the atmosphere, but it's also trying to prevent those emissions getting to us in the first place.
I'd say the thing that really is unusual and rightly scary is the idea that we can directly alter the climate by reflecting away some more sunlight. And that's scary because we have extraordinary leverage as humans. Our science technology, for better or for worse, has granted us that. So with very tiny amounts of money or effort, we could alter the world's climate by maybe putting these reflective particles, say, in the stratosphere. And that has profound implications, right up to big geopolitical implications.
Let me, before we get on to solar radiation management, let me ask you about the carbon dioxide removal. A Royal Society report here in the United Kingdom back in 2009 said that no method of carbon dioxide removal has yet been demonstrated to be effective at an affordable cost with acceptable environmental impacts. And they only work to reduce temperatures over very long timescales. It doesn't sound as if at the moment it's feasible.
I think that's exactly right, and I can say that both as an author of that report and as somebody running a startup company trying to capture CO2 from the air. So it's inherently true that anything you do, either to reduce emissions, which we must do if we want to overweight climate risk, because we must cut emissions around the world, or to take CO2 out of the air, inherently acts slowly because CO2 builds up in the atmosphere over a century. It's a long time scale.
So how far are we away from some sort of technology which could do this in a way that is effective, is not too expensive, will work in a way that can be rolled out across the planet?
So technologies for removing CO2 from the air, in this case I've got to speak as somebody running a small company doing that. I think there are small niche markets where I and some of my competitors might succeed soon, but I view our job as trying to build a tool which humanity may or may not use over the next half century. I don't expect to see really big application anytime soon.
In that case, do you think it is more exciting, this other idea of solar radiation management, where you try and in some way reflect the sun's rays away from planet Earth?
Exciting, I guess, is the word. I mean, it certainly presents more immediate security challenges and governance challenges in a way that's very different. I mean...
Well, I want to come on to those, but I want to explore, first of all, the science of it, in terms of how it can work, whether it's feasible, how much it costs. Is SRM, solar radiation management, the path which looks as if it's more viable at the moment?
No, I think it's impossible to say which is better. The fact is they're both different tools that we need to try and manage the overall climate risk, just as is cutting emissions. And there's no way to say that one is better